In this video I'm going to show you how to use an oscilloscope, this one, how to use an oscilloscope to measure AC or alternating current. Okay. What we've got here, we've got a signal generator. Now what do signal generators do? Well, they generate a signal. But what type of signal? Okay, well, the answer is actually a voltage. They're literally a voltage supply, but instead of a nice steady 50 hertz like we get from mains electricity, or a nice steady 9 volts DC that we'd get from a battery, they give a signal, a voltage that we can change. Now, with two things we can change with the voltage. We can change the frequency, okay, or we can change the value of the max voltage. So at the moment that's on max. If I take the max down to 0 or take the max up to max, we can see the amplitude of the trace changes. So how to use this oscilloscope, and how to use this in particular to measure the alternating current, or the alternating voltage rather. Well, first things, like I said, there's two parameters. This is a graph. This is a graph of voltage against time. Okay, so any oscilloscope is literally plotting a graph of voltage against time. Now, I'll quickly show you with something slightly different, and that is a battery. So a DC battery. Now this is fresh out the packet. So these square ones are actually 9 volts. I don't know if you can see that. There. Okay, so 9 volt battery. Right, now let's see what we expect to see here. Okay, so as predicted, we've still got a straight line, but it's now dropped down 2 divisions or 2 centimeters. If I swap the battery around, any prediction? It's going to go up. Okay, so there, that the height, that straight line has gone above the central line, tells us the voltage. Now, what have I got set for the voltage sensitivity? Right, now this number down here, you can see 50 volts. Now that's 50 volts for the whole vertical distance. So let's have a look. How many squares have we got? How many divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 50 volts divided by 10, that's 5 volts per division. Okay? Now, as we can see, the straight line jumps up 2 divisions. So that's given us a voltage of around about 10 volts. Okay, as expected, from a fresh out the packet 9 volt battery, always give you a little bit of extra voltage with new batteries. So 9 volts. So I'm going to leave that. We can change the sensitivity if we wanted to. I'm going to leave it, or I'll come back to the 50 volts. But if I change the volts per division, okay. Now, if I change it gone off the page here. Now, 20 volts. Okay, so that's less volts per division. Okay, so this is 20 volts. So 20 volts divided by 10 is 2 volts per division. So 2, 4, 6, 8. So it's 9. 9 is going to be halfway. So as we can see, we've got a little bit more accuracy and precision there. Okay, if we take the volts per division, well, that's the highest sensitivity, or the lowest sensitivity it goes. So I'm going to leave it like that. So we've got 5 volts per division. let's go back to the sig gen then. Let's see, so what sort of voltage are we getting from the signal generator? Okay, well, we've got maximum voltage, so it's going up to 5 volts and down to minus 5 volts. So the measurement for voltage here, well, you can have max voltage 5 volts, or with AC, peak to peak is quite often quoted. So the peak to peak voltage would be from there to there, obviously. 2 divisions, 10 volts. So this thing at the moment is delivering 10 volts peak to peak. Okay. And we can change that value by this setting here. Okay. Right, so that is the voltage. That's the y-axis. What about the x-axis? Now, with an oscilloscope, okay, get that on bang on 50. With an oscilloscope, like I said, the trace here is a graph. It's a graph of voltage against time. So, how much time is each individual square? Well, this setting down here, as we can see there, 5 milliseconds. Now what that means is 5 milliseconds is each division. So how much? So one cycle is from here to here, isn't it? So we've got 1, 2, 3, 4. We've got 4 divisions, 4 lots of 5 milliseconds. Okay, that's 20 milliseconds. So the time period here is 20 milliseconds. Okay. So the time period is 20 milliseconds. How many seconds is that? That is 0.02 seconds. Correct? How do you find the frequency? Frequency is the reciprocal of time period. So frequency is 1 over 0.02, which is 50 Hertz. Would you agree? Okay. So as we can see, we're using the oscilloscope here to measure the frequency of the voltage to be 50 Hertz. And as we can see there, it's in agreement. Well, I set it on 50 Hertz for a reason. Anyone know? Okay, obviously 50 Hertz is the frequency we'd actually get from mains electricity anyway. But with the SIGGEN we can change that. So if we increase the frequency, okay, so as we can see the wavelength decreases. Okay, we can even go up to kilohertz. Okay. So let's do one more measurement. Right, let's go with this one. Right. Okay, what I want you to do now, I want you to look at the oscilloscope. Okay, I've not changed, this is called the time base setting, by the way. Time base setting is here. Okay. At the moment it's still on 5 milliseconds. I've just increased the sensitivity. It's now on 2 milliseconds per division. So each division is now 2 milliseconds. But we were happy with it on 5, weren't we? So, what's the time period here? What I want you to do is to look at that trace, work out what the time period is. Okay. Well, what you should be seeing, okay, how many divisions? We've got 1, 2, 3, 4, 5, 6 time divisions. 6 lots of 5 milliseconds. That is 30 milliseconds. Okay? So the time period is 30 milliseconds. Right, how many seconds is that? That's 0.03 seconds. That's your time period. Right, take the reciprocal of that, 1 divided by 0.03, I think you'll find it's 33 Hertz. Okay, right, so there you have it. That is how to use an oscilloscope to measure AC. Okay, and obviously if we increase the volts per division, we can actually get a more accurate measurement for our trace. So that's now on 20 volts, okay, across the whole thing. So that's 2 volts per division. So 1, 2, it's about 9 volts peak, 9 volts or 18 volts peak to peak. Right, there you have it. Thank you.